Hello, my dear children. Today we are going to discuss the concepts or points in the exercise 2.3 in the chapter polynomials. For the exercise 2.3, we are going to discuss the concepts or the points which are useful for exercise 2.3. Are you ready to listen the class, my dear children? All of you pay attention, my dear children. Right. In this exercise, the entire exercise is based on the only one point, that is remainder theorem. Okay, my dear children. We have to learn well. We have to learn well this remainder theorem. Okay, my dear children. Right. Before going to understand the concept of remainder theorem, let us recall the previous knowledge on numbers. Let us consider two numbers, 15 and 6. We have considered two numbers, 15 and 6. If we divide 15 by 6, by using the long division, long division. Suppose here we are dividing the number 15 by 6. How many times? 6 2 times 12. Then what will you get here? 3 is the remainder. So in this long division, there are 4 parts. The number 6 is called divisor, the number 15 is called dividend, the number 2 is called quotient, and the number 3 is called remainder. Remember these 4 parts of a long division, my dear children. Just to recall that previous knowledge. Now we write this fact, we write this true statement in the form of an equation like this. We can write this long division, we can write this result as 15 is equal to 6 into 2 divisor into quotient plus remainder. Isn't it, my dear children? Do you remember? Right. If you observe this statement, if you observe this long division, what is the remainder here? 3. 3 is the remainder. 3 is less than the divisor 6. If you take any example in the long division, the remainder is always less than the divisor. Okay, my dear children, remember this true statement. Remember this point, my dear children. Keep this point in your mind. Okay, my dear children? Right. Now, let us take another example. Let us consider two numbers 48 and 6. In this case, if you divide 48 by 6 by using the long division, what do you get here? 6 8s are 48. Then what will be the remainder here? 0. So we write this long division, we write this fact in the form of an equation like this. We can write this long division, we can write this fact in the form of an equation like this. 48 is equal to 6 into 8 plus 0. Okay, my dear children? Right. If you observe this statement, what is the remainder here? 0. In this case, what do you say? We say that 6 is a factor of 48 or 48 is a multiple of 6, because in this long division we got remainder 0. Understood, my dear children? Right. Now let us apply the same concept on polynomials. We have discussed the division concept on numbers. Let us apply the same concept on polynomials. Let us consider two polynomials, 2x cube plus x square plus x and x. We have taken two polynomials. Especially this is a monomial, because how many terms are there in the polynomial? One and only one term. So it is a monomial. Here, if we divide this polynomial by this monomial, here we are dividing. Let us divide this polynomial by this monomial. See here, 2x cube plus x square plus x whole divided by x. In that case, we have to divide each and every term by x. So I wrote like this: 2x cube. First term is 2x cube by x plus what is second term? X square. X square by monomial x plus what is the third term? X by x. Understood this step, my dear children? We have multiplied each and every term of the dividend. This is a dividend. This is a divisor. Understood, my dear children? We are dividing each and every term of the polynomial by the monomial. Now come to the first term. In the numerator, what is there? 2x cube. This can be written as 2 into x into x into x. Isn't it, my dear children, or not? Yes. Divided by x. Plus here, what is the second term here? X square. How do you write x into x? X square means x into x. So in the numerator I wrote x into x divided by x. Plus here x by x. I wrote the third term as it is. Understood this step, my dear children? After expanding the numerator, we can strike out x and x. Here x and x gets cancelled. Similarly here also x and x gets cancelled. Here also x and x gets cancelled. Then what will you get here in the numerator? 2 into x into x. How do you write that term? 2x square. Understood this first term, my dear children? Right. Plus what is left here in the numerator? X. So we wrote x. Plus what will you get here? 1. So I wrote the third term 1. So this is a quotient. This is a quotient. So we can write this fact. We can write this true statement. We can write this division in the form of an equation, in the form of an mathematical statement like this: 2x cube plus x square plus x. This polynomial, the dividend is equal to, what is here divisor? Divisor is x into what is quotient here? I told you this is quotient. 2x square plus x plus 1. Here we did not get any remainder. This is a divisor and this is a quotient. Dividend is equal to divisor into quotient. In this case, here we say that x and 2x square plus x plus 1. These two polynomials are called factors of 2x cube plus x square plus x. Understood this point, my dear children? Right. Or we can say the same statement, we can say the same fact like this also: 2x cube plus x square plus x is a multiple of x as well as a multiple of 2x square plus x plus 1. Understood this point, my dear children? Right. In the previous example, when we divided a polynomial by a monomial, we got remainder 0. That is why we said it is a factor of the given polynomial. Now come to another example. See here, let us consider two polynomials, 3x square plus x plus 1 and x. Okay, my dear children, we have taken two polynomials and we are dividing. Let us consider we are dividing this polynomial by this polynomial. Which type of the polynomial? This one, monomial, because one and only one term is there. So we are dividing this polynomial by this monomial. We proceed as we have done for the previous example. So we write 3x square plus 5x plus 1. 3x square plus 5x plus 1. divided by x. What we did in the previous example, we have to divide each and every term of the dividend by this monomial. So what is the first term here? 3x square. So 3x square by this monomial plus what is the second term? 5x. So 5x by this monomial plus what is the third term? 1 by x. Understood this step, my dear children? Right. So in the numerator 3x square is there. We can expand this term as 3 into x into x. Understood this part, my dear children? In the numerator, right, divided by x. I wrote x as it is. Plus here 5x. 5x can be written as, how do you write 5 into x? 5 into x. 5 into x whole divided by x plus 1 by x. Understood this step, my dear children? Right. Now we can strike out. We can strike out x and x. Here also we can strike out x and x. X and x gets cancelled. In the first term, in the numerator, what will you get? 3 into x. How do you write? How do you write 3 into x? 3x. Isn't it, my dear children, or not? Yes, 3x. Plus, what do you get here? 5 only, because x gets cancelled. So, 5 only. Plus here, 1 by x. Because we can't divide 1 by x to get a polynomial term. So, in this case, we write this fact. We write this division in the form of an equation like this. 3x square plus 5x plus 1 is equal to, divisor is x into, what you got here? 3x plus 5, this is a polynomial, but it is not a polynomial term. So plus what is there in the numerator, we write that term, that is 1 plus 1. Understood this step, my dear children? Right. So here this is a dividend, and this is a divisor, and this is a quotient, and this is a called remainder. Is it clear, my dear children? Right. So here x is the divisor, and 3x plus 5 is a quotient, and 1 is called here the remainder. Therefore, we can say that x is not a factor of 3x square plus 5x plus 1, because the remainder is not 0. When you get a remainder 0, in that case only we can say that it is a factor of the given polynomial, otherwise not. Understood this point, my dear children? Right. Now let us take another example. How to divide a polynomial by a non-zero polynomial. Okay, my dear children? See here, let us divide p of x and by g of x. Here p of x and g of x are two polynomials in x. We are dividing p of x plus 3x square minus 1, and g of x is equal to 1 plus x. We are dividing here this polynomial by this polynomial. Okay, my dear children, please concentrate this example, my dear children. This is very important. How to divide a polynomial by another polynomial. First step, here we have to follow these steps. The first step is we have to write the divisor and dividend in the standard form. What is meant by a standard form of a polynomial? The standard form of a polynomial means we have to write the terms in the descending powers of x. First we have to write highest power of x term, next highest power of x term, after that highest power of x term. In this order, descending powers of x, we have to rearrange the terms of the polynomials. So here, see this one, x plus 3x square minus 1. So what is the highest power of x here? X square. 2 is there. So first we write this term, 3x square plus what is the next highest power of x? 1. So x plus x and last one is constant term. So we rearranged, we rewrite the terms of this dividend. Okay, my children. Similarly, here also, what is the degree of this polynomial? 1, x power 1. So the highest power of x is 1. So first we write this first term, and next term is constant term. We rearranged the terms of the polynomial divisor as well as dividend. That is the first step. Remind, my dear children, remember this point, my dear children. Okay, now this is a divisor and this is a dividend. That first part is over, first step. After that, we have to identify what is the first term of the dividend. Here 3x square. So take that 3x square by what is the first term of the divisor? X only. Take x only, not x plus 1. Remember this point, my dear children. Here first term of the dividend by here first term of the divisor. Understood this point, my dear children? Remember. Now we divide this term by this term. So 3x square. This can be written as 3 into x divided by x. Here x and gets cancelled. Then what will you get here? 3x. 3 into x. What do you write here? 3x. So this is a first term of the quotient. So we wrote here 3x. We wrote this term here. That is first term of the quotient. After that, we got here first term of the quotient. After that, we have to multiply this quotient and divisor. So 3x we got here quotient into what is the divisor here? X plus 1. So we have to multiply these two expressions by using the distributive property. Do you remember the distributive property, my dear children? So 3x into x plus 3x into 1. This is called distributive property. Okay, my dear children. So 3x into x, what will you get here? 3x square plus 3x into 1, 3x. This is a product of these two algebraic expressions. Now we have to write this product here in the second line. In the second line, we write 3x square plus 3x. Now we have to subtract this polynomial from this polynomial. You know how to subtract a polynomial from another polynomial. So here in the column, we are using here column method in subtraction. So here we change the sign. Here plus 3x square is there, so we change it as minus 3x square. Here plus 3x is there, we change it as minus 3x. We have to change the sign of the each and every term. Okay, my children. After that, 3x square minus 3x square, they will get cancelled. We get 0 only. Understood this part, my children? Right. Now here plus x is there, here minus 3x. Don't confuse here. Not here plus 3x, minus 3x. Keep this point in your mind. Here plus x, minus 3x. What will you get by simplifying these two terms? Minus 2x only. 1 minus 3. What will you get? Minus 2. So minus 2x. After that, we have to carry down the next term. What is the next term in the dividend? Minus 1. We have to carry down the next term. As we are carried down the next digit in the case of numbers in the long division, we also follow the same step here. We are carrying down the next term, that is minus 1. Then this is called new dividend. Minus 2x minus 1. This polynomial is called new dividend. Again we have to divide this polynomial by this polynomial. We follow the same steps again. What is the first term of this new dividend? Minus 2x. Take minus 2x. This is the second step. Minus 2x by x, first term of the divisor. As we followed the steps, we repeat the same steps here also. Understood, my dear children? So minus 2x can be written as minus 2 into x divided by x. Here x gets cancelled. What will you get here? Minus 2. This is the second term of the quotient. This is the second term of the quotient. So we write this term as second term of the quotient part. So minus 2. After writing this term as second term of the quotient, we have to multiply this quotient and divisor as we have done here. So minus 2 into x plus 1, divisor is x plus 1. Again we use the distributive property. Minus 2 into x, what will you get? I wrote here directly minus 2x. Minus 2 into plus 1, what will you get here? Minus 2. Understood this part, my dear children? We write this polynomial just below this new dividend. Okay, my dear children? So minus 2x minus 2. Here also we are subtracting this polynomial from this polynomial. Then what should we do? We have to change the sign of each and every term. Here minus 2x is there, actually we change it as plus 2x. Here actually minus 2 is there, we change it as plus 2. Remember this point, my dear children. Changing the sign of each and every term. Okay, my dear children? Right. Minus 2x plus 2x. What will you get here? 0. The terms gets cancelled. Here minus 1, here plus 2. Minus 1 plus 2. What will you get here? 1. We stop this division here by this step because here this is constant. What is the degree of a constant term? 0. What is the degree of this polynomial? 1. So the degree of this polynomial is less than the degree of this polynomial. So that is why we stop the long division by this step. So in this case, this is new dividend is called a remainder, and the terms, the sum of these two terms is called the whole quotient. So this process continues till the remainder is 0 or degree of the new dividend is less than the degree of the divisor. What I said, that point here, the same point. This long division ends. Stop the long division when you get a remainder 0 or the degree of this new dividend should be the less than the degree of this divisor. Then we stop the division. At this stage, the new dividend becomes the remainder. This is a new dividend. This is the new dividend. This new dividend becomes the remainder. We say that this is a remainder. And the sum of the quotients, the sum of these two terms gives the whole quotient. So in this long division, this is divisor and this is quotient. This polynomial is quotient, and this polynomial is dividend, and this polynomial quotient, and this polynomial is remainder. Let us write this fact. Let us write this long division in the form of an equation. Okay, my dear children? Right. So we write this fact. We write this true statement. We write this long division in the form of an equation like this. Divisor, dividend 3x square plus x minus 1. Dividend is equal to divisor x plus 1 into quotient 3x minus 2 plus remainder. So therefore, remember this equation, my dear children. Dividend is equal to divisor into quotient plus remainder. This fact is true in the case of numbers as well as in the case of polynomials also. Okay, my dear children? Right.